today I have a very simple thing to say, so I could just show the first slide and that's it. But I will very quickly walk you through this talk. Just an idea that I've got when listening to other people was that within this field of natural computing and the morphological computing, we are actually doing something similar as people in ecology are doing. We are using nature as a free natural ecosystem services. So, and I will tell you more in the talk. But the title of my talk is Morphological Computation as Natural Ecosystem Service for Intelligent Technology. And as Susan said, for me, it's not the central question whether the computation I'm using is substrate independent or generally valid or abstract or whatever. It's important for me that it computes what I need it to compute. In different contexts, it could be different computers and different machinery. But I'm trying to move in this. Just a second. I don't know why it is not moving. Okay. I seem to be so. Yeah. So to state the obvious, the basic idea of naturalist info computational framework, or in all natural computing, is that we are trying to learn from nature. As many of you already pointed out, it's really so long time of evolution that is used for natural systems to refine their abilities to compute or to process information intrinsically, that they are really very, very effective in resources. So when we think about Turing machine as a representation of computation or as a computational model, Turing at his time was not worried about resources. He was thinking about infinite time, infinite space, infinite resources for his computation. However, today, when we want everything to be intelligent, we want everything to compute for us, we want really computation to be ubiquitous. It means enormous resources that we are taking from nature in order to get our computing machinery running. So you know how much deep learning is using energy for training of their networks. There are enormous amounts of energy, and internet is using energy, and our communication is using energy. Energy and also materials, many different exotic materials that we want, that we need to put in our mobile phones, in our computers, in order for them to work as it is today. So there are enormous resources we are using for today's computing. And what we really need to do in the future is to radically, dramatically go down in consumption of both energy and also material resources for our computation. And the good way is to learn from nature how it is possible to compute with minimum resources, with minimum energy, in intrinsic way. So we use something that is anyway happening in nature, like reservoir computing, and use it for our purposes, to interpret it as something that is interesting for us. So that is the idea, that we can use a morphological computation, which is intrinsic computation in the world, in order to support our intelligent technology. So we don't need to run different levels of computation in order to get abstract representations and general solutions. We can use specific natural solutions for specific problems. And this is just the slide showing what is the domain of natural computing in general. And it just reminds you that it is human design computing with inspiration from nature. So we can still learn a lot, as Guillermo just newly claimed that, for example, for our technologies, for real-time technologies, we can learn how to manage things much smoother and better with help of natural solutions. And the same thing for Rao's talk. And we also can use directly natural materials to compute. And that is something that we have heard in previous talks as well. And this is a reminder of what are natural ecosystem services. So there are many and varied benefits to humans provided by the natural environment from diverse ecosystems like agroforest, grassland, and aquatic systems. These ecosystems offer, for example, natural pollination, clean air, clean water, extreme weather mitigation, the composition of waste, resilience, and productivity of food ecosystems, and human mental and physical well-being. So we just use natural processes that will happen anyway in nature to do something that is of interest for us. So in much the same way, we can say that natural computing or morphological computing and unconventional computing uses already existing processes in nature to perform computing in a typically resource-effective and ecologically sustainable way. So those are, as Lorenzo says, domesticated wild processes that we domesticate for our own purposes. So the idea is to first understand what is going on in nature, and the other is to go to the technology and apply and test how it works. And when we learn on a simplified example of technological processes how it works, we can go back to nature and see, does it remind something that we find in nature? And then go back and forth and refine our solutions for technology. But in this process, we are learning a lot about nature and how it works and how processes, how we can understand computation on the level of natural processes. So when we talk about intelligence, and that is also mentioned in both Aaron's and the Rao's talk about levels of organization and how intelligence is changing or emerging from physical to higher virtual levels. It's what we search in nature for those mechanisms, and then try to understand how we can put it into our intelligent technology so that it works much more effective and much more ecologically sustainable. So that's the very simple thing. And we are still very far from understanding how those mechanisms work in nature. So our talk, our keynote dialogue yesterday with Michael Levin and Aaron Sloman shows Aaron representing the questions and the technology and our ambition, what we want to solve, and Michael representing what we are discovering about how nature actually works on the level of cognition of a single cell, of a tissue, of a cell colony, and so on. So there is still a lot to discover in order to be able to really implement those principles and solutions that are acting in nature. But we are also, at the same time, we are building the framework, the notions, the concepts which are necessary, the languages which are necessary in order to really learn what is going on in nature and to apply. So there was a huge discussion, and still is. Can we really say that cells are cognitive systems? In which sense are they cognitive? What is cognition? We have heard this question, and it is far from clear what it is, and that's what we are working on to understand how much can we borrow from the behavior of biological systems. For example, Stewart in 1996 claimed that cognition is life. That's his synonymous. And that's the even earlier, Maturana and Varela claimed the same thing, argued the same thing, that the process of life is equivalent with the process of cognition. Everything that is going on in the cell is in a function of cognition. And today, Levin and his collaborators are both experimenting and also theorizing about first the cellular basal, what they call basal cognition, and then the cognition of the swarm of cells or the tissue made of cell of organs and so on. So we are moving forward. The first ideas were quite a lot of speculative, but today we are really getting at experimental results and possibilities to really know on the practical level how to use the same design principles that we find in nature, also applied into our especially intelligent and cognitive computational technology. So my conclusion is that there are so many open questions that we have seen these 2 days of conference, which we want to know answers to. And we have a long way in front of us on this journey of learning from nature for the engineered cognitive systems. So efficiency, resource efficiency, especially energy efficiency, is a huge question. So I think I would stop here, and I have a lot of references and my own reflections and thoughts connected to this, even in the context of Luciano Floridi's ideas about first and second and third level technology. But I will stop here, and I will not go into any more details. I think this is the essence of what I wanted to say. Thank you.
Thank you, Gordana.